Hello students, I welcome you all to Current Affair Lectures by Azad ICS Academy, and today we are going to look at the current affairs of 28th of March. Right, so this month has also come to an end and we have left with another 2 months for our prelims this year for UPSC. Right, so I hope these classes are helping you. I know we are not covering many of the topics, but most of the important topics from which the questions can come are being covered in these sessions. Right, so let us see the today's topics. Before we go for the topics, we will see the questions that we had discussed yesterday. So the fundamental force that governs, the fundamental force that governs the beta decay is the weaker nuclear force. That is the right answer, right? And what is the name of the reef that got affected by the mass bleaching event in the Australian western coast? And I think we had seen this very clearly, and that was Nagalu Reef, right? So these are the two important questions that we had discussed yesterday, right? So I want you to do a little research for this particular question. There is a topic called radioactivity, okay? And there are elements, not all elements are having this property of radioactivity. Radioactivity is present only in few of the elements which are called radioactive elements. For example, you have uranium. This is one of the important element that is present in the nature, and it can give out some kind of radiations. The kind of radiations it gives is alpha particle or alpha radiation, beta radiation, and then we have gamma radiation, right? So it is talking about the beta radiation here. So this is because of the weak nuclear forces that we have. Okay. Or another important topic that comes here is nuclear energy. Right. So these are the topics or concepts that are very important. UPSC keeps asking questions on these as well. So try to have some basic understanding of these topics as well when it comes to, because it's also there in the current. That's why have a basic understanding about these topics as well. Now, let us understand the first important topic that we have for today. It's a very small topic, but very, very important topic. And that is early alert for, what is the early alert? Basically, it is for forest fires. Okay. So there is an innovation and engineer during the presentation of Selvagard, the first autonomous AI-based drone system for the early forest detection in Elbswade, Eastern Germany on Thursday. So what has happened here is there's a place, okay, in this particular place, they are trying to test and have a autonomous drone or a AI-based drone system, okay. And why are we using this? It is basically used to detect the early forest fire. See, whenever there is a forest fire, there is huge amount of carbon dioxide that is released and a huge amount of destruction of the forests. Again, the carbon sink is going away. So hence forest fires are not a good sign in any ways. So it's very important for us to identify if there are any forest fires that are going to be there in the future. And for that, we have an engineer representation. Okay. And the name of that particular project that is there is called as Silvagard. Okay. So what is this exactly? So Germany has introduced a Silva Guard, an AI-based autonomous drone system for early forest detection, enhancing wildfire prevention and environmental protection efforts. So what are we trying to do here? We're trying to reduce the wildfires that are happening and, avoid them or reduce them and protect the environment. Right? So these are things that we want to do. Now, what is this exactly? So this is something that is in the news, Silva Guard. Okay. It is a autonomous AI-based drone system, okay, that is going to detect and suppress. Now, it is developed by, why it is developed by something called as DRYA, DRYA, the Dyad network, and work in the combination with Selvent Systems, a solar-powered wireless network. So it is going to have a solar-powered wireless network. Okay, so it is using the AI-powered sensors to detect wildfire smoke and differentiate it from the sources like vehicle emission reduction, reducing false alarm. So what is going to happen here is this, there will be AI drone which will have a sensor, okay, and this sensor will understand or will be able to detect whether it is a forest fire smoke or whether it is a smoke that is coming from the vehicles. So we will be able to, or this particular sensor will be able to give us a proper understanding whether it is a smoke that is coming from the forest fire only or no. So it's going to be very accurate. Once the fire is detected, the AI-driven drone autonomously assesses and help suppress the fires, ensuring the rapid response. So what will happen is once we know that there is a forest fire, then this particular drone is going to help us suppress this kind of fire. The system significantly reduces the fire response time, helping the prevention of large-scale fire destruction. So the time taken, see, I'm not saying that the AI will completely stop it, but the time taken in the response, if we know earlier that there is a forest fire, it can be easily resolved. The response time for this particular disaster will be less, and like this, we will be able to reduce the impact of it. Salvaguard has successfully determined unauthorized wildfires in minutes, proving its efficiency in wildfire management. So in minutes, it can detect there is fires. So hence, because of this kind of situation, this particular salvaguard becomes very, very important, right? So this is an important topic that we have for today. And the next important topic that we have for today here is related to market business. Let us see that. That is nothing but green iron is a prize worth million winning this trick. Okay, so what is this green iron? This is a part of economy. Okay, decarbonizing the steel industry is crucial for reducing global emission. So decarbonizing means reducing the carbon from the steel industry is something which is very, very important. It's a massive challenge in meeting the climate goals, but could end up being extremely profitable or companies and government prepared to take risk. If any government or if any company is trying to take risk, then for such kind of people, it's a very good chance that they can, earn money. So transitioning to green steel using hydrogen-based technology requires massive investment, international collaboration, and government incentives to ensure economic viability. These are some of the things that are required so that we can change from a normal iron or normal steel industry to the green steel industry, right? So let us understand the green steel industry and the carbon emission. See, the steel industry contributes to 7 to 9% of the global carbon emission. So 7 to 9% of the emission is coming from where? It is coming from the steel industry, the largest single industry contributor and thus prime target for net zero by 2050 goal of many countries and companies. So many countries and many companies are trying to do what? They are trying to reduce their carbon emission from the steel industry. See, steel is very, very important. Okay, it is a backbone of industries because any machines that you're making, anything that you're making is made out of steel. And the steel is used in your multiple manufacturing industries. So what happens is automatically the steel industry is contributing to 7 to 9%. So all the countries which are trying to, reduce their carbon emission, so they will try to reduce this only. Many countries, many companies are trying to reduce their uh, emission from the steel industry. The main source of emission is converting iron ore into pig iron, which releases or which relies heavily on the coal. Achieving net zero emission by 2050 requires transforming this process. So where is the process basically? Where is it exactly happening? How is it? See, the problem is that 80% of the steel emission comes from the single step in the process, namely turning iron ore into pig or crude iron by removing the oxygen and other impurities. And this process is now involving using a lot of coal. So there is a process, okay? See, if you have studied it in 8, 9, 10 standard, there is something called as purification of iron. So there is a blast furnace. Okay, if you might have seen this kind of a furnace that will be there. Okay, in this furnace, this will be a furnace. Okay, in this furnace, iron ore will be put along with some other ingredients as well. And what happens here is, I mean, it will be washed before and it will be subjected to many other things. And this is a blast furnace. If you have heard of this, this is basically a blast furnace in which the iron is basically purified. So there will be very high temperatures like 1000 degrees Celsius and more than 1000 degrees Celsius. And in this case, what will happen is the iron will come and settle down here. And there will be something like, impurities that will also be settled down here. So to get the crude iron, that is from the iron ore to the pig or a crude iron, what we're trying to do here is we're trying to mix it with other things like we are using a lot of coal, especially to burn. Blast furnace means we need to give that much amount of energy here. How is this energy coming here? We are using the burning of coal. And when you're burning coal, what is going to be the byproduct of burning of coal is nothing but the carbon dioxide that you're going to get. So understand this. To make steel, you need iron. And in iron industry, to get the crude iron itself, you're using so much amount of carbon or coal. And when you're burning this, you're getting a lot of carbon dioxide emission. So this is something that is very, very important step that you need to understand where is the problem. The good news is that there are available technologies that can that can take coal largely out of the mix. And while the eventual finished steel will not have or will not be emission free, it is possible to get the carbon intensity down from 300 kg, that is 661 lopes per ton of steel for about 1/7 of the current 2.2 tons of emission. So what we have to understand is new technologies can reduce the carbon emission. How much it can reduce the carbon emission? To 300 kg per ton steel. So right now, right now you can see it is 2.2 tons of emission. Okay. So currently, this is the rate. What is the current rate? 2.2 tons of emissions are happening of emission to get so much amount of steel. Okay, or for about 1 ton of steel. But we can reduce this to how much? We can reduce this to 300 kgs of emission only. So look at the amount of energy, emission that is getting reduced, right? So the technology involved using green hydrogen instead of coal. So what are we using? We are going to use green hydrogen. So here we are using coal. Instead of that, we will be using what? We will be using green hydrogen or hydrogen energy. But the bad news. The good news is that we can reduce the amount of emission, but the bad news is also there. And what is the bad news? Okay, these technologies involve using, though steel will not be completely emission free in this case, right? But at least the emission will be significantly reduced. Now, what you have to understand here is the bad news is that adopting these technologies at a necessary scale requires not only huge capital investment, but massive amount of cheap energy, green energy, and coordinate government regulations and incentives across the countries, from producing countries like Australia to steel makers like China and Japan. So these are the producers, okay, like Australia, to steel makers like China and Japan. So what you have to understand is the bad news is that these technologies are at a are not at a very necessary scale that is required. I mean, it requires a huge amount of capital, it requires a huge amount of, money, and it requires a huge amount of cheap green energy. Okay. And it needs to coordinate with the government and regulations and incentives across the country. So if this kind of coordination is there, that is when this will happen. Otherwise, whatever we are discussing, the solution here, the good news that we are discussing is not going to remain good news unless and until we are going to come up with this kind of a coordination with the government and we are not having these technologies. Right. So transitioning to this particular green steel requires massive capital and cheap green energy. Government must coordinate, have such a kind of a policies, incentives, etc. So to make this resource producing and steel making countries, hundreds and millions of dollars are needed to build and require such kind of energies to produce. You need hundreds and billions of dollars. Right. Now, apart from this, we'll see Australia's iron ore exports are worth about, you can see, $85 billion per year, and metallurgical coal is further 34 billion. But the potential increase in the value by switching to production of green iron for export was as put as high 252 billions in a year. This assumes that converting most of the current iron ore volume to green iron through this process of using hydrogen made from renewable energy such as solar and wind. So what you have to understand here is currently, if you see what is the worth of Australia's current iron ore, it's somewhere around $85 billion. While if you're including all the coal that gets added is $35 billion. Okay, converting it, the increase export value, whatever you're exporting, the value would get increased, no? How much it would get increased? It would get increased to 252 billions per year. So a 40% of conversion by 2050 would still require $110 billion. So here the more realistic view of converting 40% of the ore output to green by 2050 still and yields an impressive value around only 110 billion per year, to which a country is going to add a lot of value to other 60% of iron ore still being shipped. So you need to understand that we are saying, okay, there's a good news, but the amount of money that is required. Look, if you're doing it right now, you're paying only this much per year. And if you're doing it using the green energy, you have to pay this much money. Right? So these are some of the things. But yet building the energy that produces infrastructure to achieve will require massive amount of capital running into hundreds and billions of dollars. But before such huge amount of capital are deployed, investors will have a high degree of certainty. So we are, investors will think about when they are investing in this kind of situation, right? So commitments that are needed. We have to understand steel mills in Japan, China, and South Korea must commit to buying green energy. So these are some of the things because they are producing high amount of steel. So they are heavy weights like China, Japan, Korea will have to commit that they will buy green iron. Okay. This must switch to electrical arc furnace, which do not require coal for smelting. The smelting process is, burning the ore with the presence of iron, presence of oxygen in a very high temperature. That is the process of smelting. Smelting is nothing but it is one of the process in which what we are doing is, say this is your blast furnace. This is how the blast furnace will be. In this, the ore will be put along with the ore. There will be they allow the oxygen to go in and they melt it to very high temperature. And this process in which the ore is burnt, ore is burnt in presence of oxygen. So you can see here. This means that they will commit to capital to switch steel production from the coal intensive basic oxygen blast furnace method to using electrical furnace. So this is a basic method. So instead of using this, we are supposed to use electrical arc furnace, which can be produced using green iron into steel without using coal for smelting. Smelting is a process wherein you are taking the ore, burning it in presence of what? Oxygen, the normal coal process. Okay. So instead of that, we can use something which is called as electrical arc process instead of using the normal coal process. Mining companies must invest in renewable energy and hydrogen production. So this is what they can do. Steel makers can invest in Australia's green plant and also share up the capital. Miners are the good in diggers and chipping iron ore. So they will also have to learn how to process the raw ore into pig iron using the hydrogen, green energy, which is effectively meaning they will be able to find out a partner which are doing renewable power plants, etc. Right? So now, what you have to understand here is role of the government. How can government basically play an important role? See, green steel is more expensive to produce than the traditional steel. Government must introduce carbon tax or subsidies to encourage such kind of a transition. So government should give some kind of rebates, some kind of subsidies. Okay, if they are producing steel using green energy, they will not collect so much amount of tax. Okay, consumer demand alone may not be enough to drive the change. So need of the transition. See why there is a need for us to transit. See, the transition to green steel requires strong initial efforts to, maintain momentum. Collaboration among the minor steel producers and government is essential. If successful, the shift could create more sustainable and profitable steel industries. So if we are able to do it, then what is going to happen here is that it is going to be very important. So here you can see right now the green energy dream is like a small snowball at the top of the mountain to start rolling down and gain size, speed. It requires some kind of initial momentum. So obviously it will require some kind of initial momentum. But what we have to understand here is that if this ball is getting momentum, if it becomes big, then it's going to be very, very big, right? So we have to understand that there is a lot of potential here, right? If we can do, I think there will be a lot of reduction in the emission of carbon dioxide, a very good news that we have. Now let us see the important questions that we have. What are the primary alternatives to carbon in the coal in the green steel production? So is it natural gas? Is it biomass fuel? Is it nuclear power? Is it hydrogen producing from the renewable resources? Try to find out the answer. Okay, which countries are mentioned in the heavyweight in steel production that needs to commit to buy energy? I think all of you can easily find out this answer as well because this was there in the this particular slide. So steel mills in existing heavy weights like China, Japan, and Korea. This is the answer over here. And hydrogen. So I've been telling about green hydrogen. So green steel production would be obviously related with green hydrogen. But try to find out more about what is green energy. Okay, in India also there is a lot of thing that is happening when it comes to green energy, hydrogen energy. So try to have a look at green energy a little more in detail so that you can connect the current affairs to the uh, static part as well. So I'll see you guys in tomorrow's class. Thank you so much. Have a great evening ahead.